we need to know, we need to figure out at what rate was the top of the ladder going down. So we actually need to find this rate. So let's label this side first. Let's call it Y. And therefore we need to find dy dt. So I need to find dy dt. I need to label this side, the bottom. So let's make it x. And that's about it. All right. When I give you problems like that, they involve the right triangle, and obviously you have to deal with a Pythagorean theorem. That's the only thing you want to start with. What else? By the way, I hope you understand this part. The hypotenuse of this triangle C is always constant because the ladder doesn't change. The length of your ladder is the same. It doesn't matter whether it's sliding or it's on the ground or it's in a vertical position. It's still that same ladder. So C is 25, but it's constant. It's very important. All right, let's start with the Pythagorean theorem. So we have x squared plus y squared equals c squared, but I'm going to put 25 squared. Notice that the values of x and y will change as the ladder slides. Now, as I said, the ladder will be still 25 feet long. So let me differentiate both sides now and see what happens. Implicit differentiation. So 2x plus, I just said implicit differentiation. Since x is changing, it's not the same, then you have to put dx dt. The only thing is the same here, constant. It's the length of your ladder. Now, plus 2y, the y is also changing, dy dt, and since the derivative of constant is 0, so I'm just going to put 0. Now it says the base of the ladder is sliding away from the house at 2 feet per second. So that means here, one more time, this value, dx dt, is 2. So I can replace my dx dt with 2 later on. Also, let's see what else we have. Also, the problem states that x equals to 17. If you read this question, it says at what rate was the top of the ladder going down? Was going down when toward the ground, when the base of the ladder was already at that moment 17 feet away. At that moment, 17 feet away from the house. So that means this distance is 17 at that moment. So x you're going to replace with 17. So right here, this x would be 17. What else do we have? We don't know what this value is, the y value, but it's a Pythagorean theorem, so we can always find it. So we're talking about the length of the ladder. It's 25. At that moment, it doesn't matter It's still 25. At that moment, the value of x is 17. Now we just need the value of y. So according to the Pythagorean theorem, x squared plus, I have it on the top, plus y squared equals 25 squared. Therefore, x is 17 squared plus, I don't know what, squared equals 25 squared. And if you solve it, you'll get y equals, it's not a perfect square, so that will be 336. So I think we are all set. So let's put it together. We get 2 times x, which is 17, times dx dt, which is 2, plus 2 times y, y is 336, times dy dt, and that's exactly what we're looking for, equals to 0. 2 times 17 times 4, you can do that. Oh, I'm going to move to the next page. You know what, this is simple at this point. If you do it right, you're supposed to, you can finish it up, and you will get dy dt approximately equals to negative 1.855 feet per second. Units are important unless it's multiple choice. Also notice it's negative because the length of y is decreasing, the ladder is sliding down, so that's why it's negative. I'm going to actually show you more examples. So here's another good problem. So you have this conical shape, and it's a cup, and it tells you that the height of this, sometimes they give you unnecessary information that you don't even need. That's how they trick you. The height of this whole thing, of this cup, is 4 inches. It says right here. And it says the volume is changing at the rate of 2.5. It's right here. So you're getting more and more water in that cup. The base of this cup is 3 inches. So that means this distance is, the radius is 1.5. And then they ask you how fast is the level of water rising in the cup when the liquid is 2 inches deep. Alright, let's see. First we want to list all the information we have, including the formulas. So I would start with the volume formula because that's the most important parameter here. We're going to deal with this function. The volume of a cone is pi, you have to memorize this by the way, r squared, area of the circle, times h, the height. Now we also know that the volume is changing, dv dt equals, and it's positive, it's increasing, 2.5. That was inches cubed, I think, per minute. And the height of the cone is 4. The diameter is 3. Okay, we got that. So radius is 1.5. Got that. And it says well, see, when you get to, let me go back, when you get to this level right here, you don't know what radius is. So we should label it r. And we don't know what this height is going to be, so let's label it h. Well, it's changing, in other words, I'm sorry. So the radius is changing, and it's getting bigger and bigger. The height is changing, the level is getting bigger and bigger. So that's why I marked it R and H. you can clearly see the two triangles. You know what, I'm going to redraw these two triangles. It's right here. So one big triangle where this value is given, the length of this side. A smaller triangle, we don't know what r is, it's changing, and we don't know what this is, it's also changing. But we do know that the whole thing, the distance from here to here is 4. That's all we have. Now, the similar right triangles, we just we got the two similar triangles, and we can actually use the geometry strategy and write very important ratios. Now, since corresponding sides of similar triangles are in proportion, you can set up a beautiful proportion here. So I would say it's 4 over h, longer over shorter, equals 1.5 over r. So I hope you agree with me on this one. And we can solve this proportion for r. We have to. Otherwise, in your volume formula equation, you're going to have two variables, r and h. And then how are you going to find the derivative? You have r and h, and it's going to be implicit, and you're not going to have enough information to use, so you'll get stuck. So you use this proportion to find the to express the radius, and that would be, actually, you know what, if you express 1/2 as 3/2, that would be easier. It would be just cleaner, and your equation would look like this: 3h over 8. Try it out somewhere on a piece of paper, you'll see. R equals 3h over 8. Now if you substitute this for r into the volume equation, the problem of knowing nothing about r is completely solved. So here, a volume equals 1/3. Sorry, just want to look one more time. Here I made one mistake. It's supposed to be 1/3. Okay, 1/3 pi r squared h. Now what do we have? 1/3 pi, we just found r, is 3h over 8 squared h. So if you simplify, you'll get v equals 3 over 64 pi, what is it, h cubed. Yep. Alright, now find the derivative with respect to t, and you'll get dv dt equals since you're gonna take this 3 and bring it down, so that becomes, your constant becomes 9 over 64, and then you another constant pi, and then you get h squared, but h is changing, so you have to put dh dt. Now if you go back and check and see our given information, you'll see that d v dt is given. Now I remind you, dv dt equals to 2.5 units. So therefore, you can rewrite it as 2.5 equals 9 pi over 64. dH dt I don't know. By the way, H is 2 because they tell you that the level of water in your cup is 2 inches exactly at that moment. So it's 2 squared dH dt. And that's it. Now if you solve it for dH dt, you get, okay, 4, and you can reduce this fraction, 4 and 64, multiply by both sides. So I believe you get, I'm going to use calculator. 4.15 inches per minute. Oh, so important. Units are so important. And that's it.